Hello, everyone. My name is Francesco Cipollone. I'm the CEO and founder of Phoenix Security. I'm coming here today to say that I never fix a critical vulnerability. I never fix a critical findings. That was reported by two. And you might think I'm completely crazy. And my CIO thought that I was. Security is important. Security is everybody's responsibility. But the truth of the matter, security is not a security problem. Security is a business problem. Tell me how many times lip service of security is everybody's responsibility has actually turned into action and fixing vulnerabilities. Only when this was a business requirement. And the challenge that we have nowadays is translating business requirement, high level objective of like, I want to be secure, to what that actually means and how that is actually action. On the other side, what I was doing day in and day out was actually reducing risk to the tolerance where the organization wanted to be and how at risk the organization wanted to be. And that changes dynamically because of new critical vulnerability coming out, new perception of risk. And I say perception versus data, they're two very different things, but as security professional, we need to address them both. Let me explain how we did it. And let me take you on a data with vulnerability that was our approach and my approach on data-driven risk, data-driven and risk approach on vulnerability. This talks is about research that we did, and I'm going to walk you through the various source of information around just one of the elements that we have, that is exploitability, but it's a very useful tool to look at what are the different data sources and how different data sets can lead or mislead you to think that you're safe or you're not safe or you're too safe. And with critical vulnerability being at the historical high level across software and across vulnerability management, we're going to go through this journey together. I apologize in advance because I make an enormous use of memes, and security is already a heavy enough topic, and vulnerability management is a topic that is particularly heavy. We don't need to make it even heavier. So let's make into a joke and a smile. A little bit of background around me. I'm Francesco Cipollone, Frank for friend. I'm a founder of Phoenix Security, and I'm a speaker, I'm an AppSec professional, an AppSec passionate, and AppSec and CloudSec and risk focused person. I've been doing this work for a very long time. I've been advising CISO on how reducing risk for 10 and plus years, and I've been speaking extensively about the subject and the topic. I've been also part of the Cloud Secure Alliance, of which I'm still on the board of directors, and currently working on Phoenix Security on solving this problem in a dynamic and intelligent way. And one of my mantra has always been, you can argue with people, but you can't argue with data. And there are people that disagree and agree. It depends. There are nuances in that on the data set that you choose to agree and argue with. So from data scientists, there is always argument around which data set you want or you don't want to use. But this is much more heavy in terms of opinion when you can back your opinion with data and data set. It's very hard to argue with that data set. And data-driven approach, I learned during my career that makes a very compelling argument. So what we're going to go through today is an introduction, is security versus development. Why is it so challenging to convince people to fix vulnerability? Which vulnerability to fix first, and focusing on reachability, context, and exploitability. There are three different, very, very different subjects that interrelate to each other. And then we're going to dive in the data-driven approach on exploitability. We're going to see the approach between criticality, popularity, and exploit, EPSS, and the various edge cases. So the thing that I want you guys to go away with and focus in is exploitability, what it is, and what are the data sources that you can reference with and when to use it. how to use this in a risk formula, and how to discuss more about risk perception rather than actual vulnerability, actual critical, and backing all these things with data. Now, I feel your pain. I've been through this journey. I've seen this scenario with several tools, with critical across the board, with everything screaming at you, and the subject of who should fix, what is most urgent, and where you should focus on. And when we mention security is everybody's responsibility, is it actually? What happened to the rest of the task that the business has and the various development team have? We need to interleave what we want a security professional with what development team have in their backlog, and understand that every sprint they need to battle between bug fixes, developing new features, and fixing security stuff. And that's mainly driven not by security, but by the business. And hence why I say security and vulnerability, and selecting which one to fix or prioritizing which one to fix is a product and a business problem. Now, security jobs is to always give a clean cut, or as clean as possible, sub-selection of vulnerability to fix, and helping developer getting there faster with speed without blocking them, and collaborating with them. Because usually our approach is, hi, here's a vulnerability report out of this end tool. Great, we managed to find problems. Are you going to fix it? And as I said, I love memes, so I usually use these jokes. Are you going to at least look at the critical? Are you at least going to look at the exploitability? That's usually not going to happen. And then when you start discussing with risk, usually that's a spreadsheet sitting somewhere. It is very difficult to action, because those risk elements are very fluffy, a very high level. Identity is a problem, but what that means and how we mitigating that problem, what are the actions? It's difficult to translate that very high level statement. We should have zero critical vulnerability. Good luck with that. That's a policy and a statement rather than something that is actionable across the board, because not every application even have development team. So the whole topic of vulnerability is backed by one big challenge, that identifying what to fix first is very hard, and it's not always straightforward. Why, you ask? Well, for a very simple reason. You have tons of vulnerability, very few security team, and a lot of development, and a development community grows, and the engineering community grows, while the security team can't grow at the same pace and at the same speed. And we try to approach this problem with security champion, with our extension to the security team, but we need to have metrics to drive fundamentally security champion programs, and we need to have data to help them identify what's fixable and where to focus. Because the usual argument is, and I'm going to quote Gartner, I'm going to go Ponemon Institute. So those are data sets. Friend don't make friends mention those elements. But out of the data set, I'm going to mention a few statistical elements. They're going to back somehow those numbers. And again, you can argue with data in the data set that you choose, but overall, not all the vulnerabilities are exploitable. Only a very finite number that revolves around several elements. Very few are reachable, and very few are attacked now at scale. So this is an overview of the exploitability versus the amount of vulnerability actually exploited at scale and exploitable at scale out of an IBM research and a Gartner research. It shows, without diving into the data in the data set, it shows where are all the vulnerabilities, and the number of vulnerabilities you should really focus on that are really actually exploitable. Now, if you take on reachability that we're going to attack in a second in terms of topic, we're going to even reduce that number. But the rationale to do this is not fix slow. And again, this is a Gartner report, but to fix faster and to focus on what's really important in the more critical and high, and really focusing on the critical and high that matters. Because focusing on SLA only doesn't work, doesn't cut out. And the target versus the amount of objective that organization hit is always higher. So if you see here, organization never meets the SLA target expectation across the board, also because this is a widespread number and doesn't have very precise information. So some team might hit them, some team might not. Now let's dive deeper on a couple of caveats, that is reachability, exploitability, and context. And risk is a great unifier because it can express all of these elements together and can amalgamate all of these elements together. Now let's focus on the first element. Let's say we have a library that is log4j, or any other library that you might have. Now this particular library has a specific function that is storing a specific set of log or things like that. I'm just going to mention an example. Now, it's just a matter that if your line of code calls that particular library and use that function, that particular piece of code that has vulnerability is actually affecting you. Now, potentially your code might evolve and in the future might have vulnerability across that. But it's not always true. So fixing vulnerability or upgrading a library on something that doesn't get called has been always the argument around development and security, but it's a really hard problem to solve and fix because your code might not call that element. Now, another element that I usually mention, and I just put some numbers here in terms of reduction of vulnerability when they're not reachable. So there is a network reachability. There is also a concept in CVSS that is network reachability or network exploitability. That is maybe another area that we're going to focus on. But I want to focus on mainly the fact that you might have systems that are directly or indirectly exposed to the web with WAF rule, with indirect WAF rule. There is another element and compounded element of like how directly exposed or how reachable are those services. And then the one that are more internal. Of course, you're going to need to focus on the one that are more external, but having a very good idea of what's external and what's internal is very hard. Now, let's focus on data and the data-driven approach. Now, in our latest research, we looked at all the GitHub repositories that are available, compared that information with several other data sets, that is EPSS, that is CISA-CAV, that is ExploitDB, and a few other data sets that I'm going to explore in a second. And basically, we looked at what's more exploitable. And if you see, there are some patterns of some vendors that are more or less exploitable. We're going to touch on the attack surface because some of these vendors, like Microsoft, have a very large number of products. So it's clear that they're going to have an attack surface that is very large, but also the speed, like Microsoft, for fixing has gone much faster. Now, this is a data set. We're going to also compare this with CISA-CAV, and the data set that CISA-CAV, we're going to see the commonality and the non-commonality. Again, you can argue with data and specifically the data set that you choose. We're going to look at two things, that is basically exploitability in the wild and CISA-CAV, again, MVD exploit, EPSS information, and more. Now, we have different concepts, and I'm going to go through different concepts just to give you an idea of what we mean for those different concepts. Like popularity for us, we've been looking at this as how likely it is to be exploited for a specific vulnerability based on the amount of information that are available out there in terms of exploit available, like pure raw data without unconfirmed things. Bug bounty probably help us narrowing down a little bit more on what's actually exploitable because those are exploit confirmed, while Packetstorm and GitHub just give us raw pieces of information that we don't have information about if it's exploitable or not. Now, zero-day is a particularly different beast because the zero-day project and Google zero-day sheets try to track vulnerability that will eventually make their way into MVD, and the time to MVD or National Vulnerability Database has been decreasing with the good and the bad that has. But zero-day tracks fundamentally things that are still not active, so it's something to keep an eye on. But the time between zero-day and MVD has been shortening very quickly. And then the other aspect is the particular piece of code automatable? And is this, we can extract that information from a network vector or the CVSS vector in the network specific area? Or does it have an RC, or does it mention the piece of code, unexploitable code that is remote code execution or RCE or something similar? Now, for exploitability, we have certain function or certain databases that gives us information if something is actually exploitable or not, and with a certain degree of reliability. Sysakev is a very good, reliable resource because it's manually, the vulnerabilities that are out there are actually verified together with the MVD verification process. But it's been widely recognized as a good data set of actually exploitable vulnerability. There is an evidence of exploiting and an evidence that something is fixable. So those sources, together with Exploitdb and Metaexploit, with verification of an exploit, are very good data sources for exploit. Now, if you have an active exploit, it doesn't mean that it's being actively exploited in the wild. So it is being confirmed, it is being reported, and also it is being used in the wild. Those are 3 and 4 elements that we could use. And that's where we go towards the intelligence aspect, where it tells us from a broad perspective, is this particular attack or attack method exploited in the wild? And then we have specific resources that tells us, is this particular vulnerability being exploited right now by malicious actors? So those two are slight nuances. Like EPSS gives us a broad overview of what's attacked at scale right now, but that might lead into occasional attack in the next 30 days. But there is a specific delay where you could be victim of an attack right now because specific threat actors are using that particular vulnerability right now, and hence it's not very popular. The exploit is still not known, but you're going to get hit. Like, well, Log4j was probably a bit of an exception, and there is an EPSS article on it. But we had movie transfer and view the Citrix vulnerability, the VMware vulnerability. We have noticed a delay between a CTI detecting it and EPSS, of course, detecting it, and you have different aspects. So we wanted to kind of focus on that. But for this particular research, we use heavily EPSS because it gives us a good information on, is this particular problem exploited in the wild? Now, if we look at criticality and how critical they are in our data sets and in GitHub data sets and in exploit available, we can see that Oracle, for Log4j, for particular Apache, and so on, are very high in the number of vulnerability detected, together follow on by operating systems. While Sysakev really focus on some similarity, like Adobe product, Apple, Microsoft products, and so on. Now, popularity for us was detecting where those exploits are and how many of those are out there, between Sysakev and the full data set. So we compare the 2 data sets, and of course, Log4j and Microsoft Exploit are probably the more widely mentioned in those 2 data sets. And on the wider data sets, Log4j and Microsoft are probably the more popular one, followed by the very common known attack like NetApp, and Apple and Debian and Apache and so on. Now we try to use EPSS. There is a debate, an argument about EPSS 0.5 and above, or 0.6 and above. We can look at the density of the data sets and where EPSS lands in terms of density between these two elements. But let's assume that for this particular case, EPSS above 0.6 is considered high EPSS. And for this, we have some level of similarity between Microsoft and Oracle still being in the pole position, and some level of information in terms of similarity between critical and, popular and EPSS information, where we have some difference between criticality, as you can see, and high exploitable EPSS. Now, another good source of information has been top routinely exploited. It is a bit more refined version of highly exploitable vulnerability, the top highly exploitable vulnerability. So if you see, there is some level of similarities again in the names, and some of the vendor might be smaller. And for this, you can see the data set below and access directly and explore the data set. But basically, those two elements are hot vulnerability, if you want, so things that are being exploited in the wild and so on. Now, other elements that can drive exploitability likelihood are, where is the data, how exploited it is. Like APSI gives us a very good information, but location of the asset, blast radius, attack path, and criticality of the asset where you deploy is important. The popularity is another factor that we considered, and it basically tells us how widely deployed are those exploits across different data sets or across different locations. GitHub, HackerOne, popularity of exploit means between ExploitDB and few other locations, if an exploit is available, if an exploit is being verified in meta-exploit, and so on. Other things that you can see in between the data set, of course, is the popularity in the various data sets. And they change fundamentally. You can see in the three elements that I mentioned. Now, another element that we can consider is the attack methods. And there is another set of research on the CWE and the methodology of attack that can be used. And of course, the top routinely exploited vulnerability. Now, on top of this, there is some consideration around the market cap and the amount of product, basically, that each vendor has. And we have two statistics around the exploitability data set. If you can see, Microsoft has a presence, but Cisco has many more vulnerability and product compared to the market cap versus the product data set on CISA where it's a little bit widespread. But in general, to say, the more vulnerability you have, the probability that you have a lot of market cap and a lot of product line. Now, there are some exceptions like Android, where there is a finite number of iOS that or operating systems that are exploitable. And those are probably the outlier where you have less product, but a lot of vulnerability. That is some red signal that you can focus on. Other consideration is we are looking at exploitable attack methods and CWE information. If we can use some of the pattern and information that we can see in the CWE information, but also CAPEC and attack methodology to see what are the most attack methodology that you can see in the wild. If you see CWE 79 is quite exploitable at scale. That has been also confirmed by the top 25 exploitability at scale, followed by the CWE 200, 287, and so on. So some data set out there. Now, if we want to focus on some of the edge cases that we mentioned already, on the top exploited vulnerability you can see in the right. One was OpenSSH, where CVSS was low. It was revisited further down, but the CTI interest score was very high, while EPSS at the beginning of the exploit was very low. VMware, again, was very low in terms of vulnerability, regardless, despite the fact that CVSS was very high and the CTI information was medium to high. So for new vulnerability, EPSS hasn't been the best information to track for. Usually there is a little bit of buffer and delay between something newly discovered and something else. So CTI, like Greynote, Shadow Service, and possibly HackerOne ranking data, bug bounty tracking data are elements that we can consider, as well as other information. Now, CISA has been a very good tool, but it lacks focus on application security vulnerability. Just a very small percentage of those vulnerabilities are actually dedicated to application security. Now, all of this to say there are tons of data sets and you can clean and cut your data. We went already through a lot of the data sets that are available out there together with exploitability and vulnerability management. A lot of these can be risk or can be translated into risk, because mentioning 6 or 7 of these data sets to an executive, usually you leave it wondering what the heck is going on here and how do I even tackle this? I don't have any way to express an opinion, so I'm going to express an opinion regardless because I'm paid for it. And that's unfortunately the reality of it. But at the other time, if you talk about risk to developer, yes, they might have a perception, but then so what? Which problem do you want me to focus on next week? I need to allocate a number of story points. I need to focus on bug fixing. If you don't contextualize for them into those terms, likelihood are that you're going to lose this audience into the development community and the executive community, and you'll be regarded as noise generator. Maybe not directly, but indirectly. Now, risk has been my favorite because it's a common language across different stakeholders, and it can be translated into things to fix first. Now, severity is usually the things that CVSS throws at us and MVD throws at us, while probability, likelihood of exploitation can use a lot of these data set, like exploitability, likelihood of exploitation, if there is threat intelligence, if there is CTI available, so can compensate the likelihood of exploitation with EPSS. If there is a fix available, if the system is externally located, and then you can also consider impact element, like how important is the asset, how many users will be impacted, and so on. Some of the elements that we can use it in automation. So some element like exploitability, active bug bounty, the vector information are fairly challenging to find, but easier to identify and use, while reachability in code require really heavy analysis on the code element and can be taxing to do across the board. Locality is an important concept that can be automated up to a point and require usually tooling and technology. That's what we specialize as well. In terms of exploitability, can you even reach that piece of system, that server, that piece of code running on a specific machine? And is there an attack path methodology? Business risk require a little bit more involvement from a business perspective, but enable us to express which is the business application that are more critical. And you have more on the harder part, fair analysis that include a chain of vulnerabilities, of direct and indirect impact analysis, regression testing. So generally speaking, it's regarded as more complex, but very precise. And last but not last is false positive, prioritization, deferred, and every other reason that a team might have to look at a vulnerability first or latest. And that's usually the best way to use the human. Now, we use the human at step number 1, usually to actually automatically triage and feed and sieve through enormous amount of data. And hence, we burn our team. So I want to leave you with a last closing thought that is, don't let the team burn out. There are data sets out there. There are data sets available. There are technology available that for a fraction of an analyst time, you can throw a bunch of vulnerability and reduce a lot of the triage time. You still require people to actually look at this refined number, but instead of looking at 10 million problems, you look at a specific aspect. So in conclusion, security is a long road and we have light at the end of the tunnel. Manual triage is completely non-practical. We discussed about it. We just referred to it. It is burning out. EPSS, exploitability, and these other data sets are an enormous benefit and available to understand at scale what is exploitable and non-exploitable. Other factors like context localization, prioritization can help, again, enhancing those things, not in general, but for your business, together with specific use of CTI to look at exploitability, but only when that CTI is used in conjunction with all these elements, because atomically, it doesn't tell any information. Yes, a vulnerability might be exploitable by threat actor, but if it's buried down the stack, likelihood of that information to get exploited is very unlikely. So only if you have a good picture of your environment and exploitability at scale, then you can have an opinion about, can this be exploited, yes or no? And then talking about risk and talking with risk with the business and development doesn't work in that specific way, but it helps creating that backbone between business, security, and development, because you can connect all of them with specific context. So I hope this was useful. I have to thank EPSS working group, HackerOne for providing some of the data, Packet Storm, and a few other data set, GitHub as well, plus all the repository that we managed to scrape and find. So all the community or security community has been great to get these data. We have a framework to use all of these together, and we have a product that automates a lot of these elements together. Now, if you want to try the product, and if you're part of OWASP, we have an OWASP edition of the product and a community edition of the product that you can try and use, as well as we've wrote tons of white papers on exploitability at scale and vulnerability management at scale, together with a compelling topics and argument around SLAs and data-driven approach around vulnerability management that include a lot of this contextual aspect at scale. So I hope this was useful. We have also a podcast where we talk around those topics a lot. So follow us on Cybersecurity and Cloud Podcast, www.cybercloudpodcast.com or www.phoenix.security. Security is in the name. /podcast. So thank you so much. Stay safe and prioritize and don't burn out.
Vulnerabilities today before attackers exploit them tomorrow. Phoenix Fix vulnerabilities today before attackers exploit them tomorrow.